Hey guys, we're at the end of the chapter. This is the chapter 11 review on page 480. Basically, we're doing all of page 480. I'm going to be doing the odds today. It's a big assignment, so that's what we're going to be working on most of the week. And if you want to split this video up a couple days, that might be a good idea. So I'm going to go ahead and jump right in on number one. It just says mentally estimate each integer. I don't really care if you mentally estimate it. You can use your calculator to help. Square root of 127. So what times what equals 127? Well, 10 times 10 is 100. 11 times 11 is 121. And 12 times 12 is 144. So what is closest to 127? That would be 11 times 11. So on number one, the closest answer would be 11. It's going to be like 11.3 or something, but they just say to the nearest integer, so 11 would be the closest answer on number one. Okay, number three. Number two, by the way, is a cubed root. So what times itself is close to 50, or is the closest to 50. So make sure you do a cubed root on that. Number three says use a calculator to approximate each radical to the nearest hundredth. So any old calculator will do. There's no special tricks. Hopefully you guys all know how to plug in square roots. It says round to the nearest hundredth. That's the second decimal place. So my calculator says 0.7937. Okay, so we're supposed to round to that place, so we look at the 3. 3 does not round the 9 up, so it's about 0.79 for number 3. And that would be it. Okay, on number 5, it says convert. Okay, this is the part I did not teach you guys a couple weeks ago, so hopefully you figured it out. Number 5 says convert each radical to exponential form. So I'll just write that down. 2x cubed. Okay. If there is no number on the radical, no number up here, that means it's automatically a 2, a square root. If there is a number, like on number 6, it is that root. So on number 6, it's a 4th root. Okay, I'm going to go ahead and write a 2 in there. Basically, this number out here is going to go in the denominator of our exponent. Okay, 2 does not have an exponent. That means it's like 2 to the first power. But since it's in this radical, it's like 2 to the 1 over 2. Okay, so this is 2 to the 1/2. Okay, when it has an exponent up here, this might be a little less confusing. For the x, right now it's x to the 3rd, but the square root, the 2 over here, is going to go in the denominator, so it's x to the 3 over 2. So you just put power over root. Power over root. Since 2 did not have a power, that implies it's a 1. So this was 1 over 2, and this is 3 over 2. If this fraction, a lot of you figured this out, but if the fraction reduces, you should reduce it. Neither of these reduce. Number 6, one of them is going to reduce. 3 over 2, you don't change it to a mixed number, though. That's not reducing. Reducing is like 2 over 4 reduces to 1 over 2 or something like that. Anyway, so that's just the answer to number 5. Pretty short. I know, hopefully didn't kill you guys a couple weeks ago. By the way, there is a quiz at the end of the week, and that's not on there, but like problems like 15 through 20, those problems will be like simplifying square root. We'll talk about that later. Actually, I just realized I did not on the homework assign 7. 7 is just backwards from number 5. So It's the same idea, just going from here to here. And I didn't sign that on the homework because didn't want to overload, but so I think we'll skip it here too. So we'll skip 7 and 8. And jumping into number 9. Number 9 just says simplify. Actually, this is more like the stuff that is on the quiz at the end of the week. Number 9 doesn't really need any special tricks. It says cube root of -8. So what times itself equals -8? There actually is something that works for this. 2 times 2 is 4, times 2 is 8. And if you do -2 times -2 times -2, that would equal -8. So it is -2 because -2 cubed would equal -8. Hopefully you guys, every calculator should be able to do this. And so if you plug this in your calculator, you should get the right answer. Not every calculator can do every problem, but this problem they should all be able to do. If you haven't figured out how to plug this in yet, you need to go ahead and do that. And we probably done it before, but you might have forgot. I don't know. You might Google it because we all have different calculators. If you can't figure it out, it's in your instruction manual of your calculator, I'm sure. But anyway. Number 10 is different than all the rest, so I'm going to mention it. If you have a negative under the square root, you plug that in your calculator, you should get an error. Why does it say error? Because you can't have anything times itself equal negative, any normal real number times itself doesn't equal negative. So 10 is just not real. Okay, number 11. This is really what will be on the quiz. We'll keep that up there. Square root of 84. Okay, most of the quiz is going to look like this. I'm going to go ahead and put that at the top, I guess. Okay, simplify means no decimals. We want like the answer to stay with a nice clean answer, like 3 squared of 8 or something like that. So no decimals. You can't just plug it in the calculator. Some Casios, the decent Casios, can do this without a problem, but the Casios can't do cubed roots or anything bigger than a square root, and they also can't do letters. So we're going to need a little bit more in a Casio. But on number 11, Casio should be able to do. Okay, for the rest of us, we're going to have to simplify using the tree method. And what times what equals 84? Well, if it's an even, you can always set 2 will always work, right? If you can think of something bigger than 2, that might help break it down a little quicker, but start with the small numbers if you're not sure. I'm going to use 4 because I can tell 4 goes into 84, and that's going to be 21 times. So 84 divided by 4 is 21. 4 is 2 times 2, and 21 is 3 times 7. Those are all primes, so those branches all stop. Okay, so what we're going to do is take the doubles and put them in front. So I see a double 2, and 2 times 2 is 4. That's going to go in front. Okay, 3 and 7 do not have any doubles. So they're going to go back. 3 times 7 is 21. Okay, the stuff in front, the doubles, should always have square roots, because square roots means what times itself equals that. And if we have doubles that we use to get that, it's going to have square roots. Square root of 4 is 2. Square root of 21 does not simplify. So that's all we can do. They probably should be a little bit closer, but that just means 2 times square root of 21. The end. All right, number 13. Similar, but there are letters involved. I'll probably... Well, 12 is a tough one, so I'm going to go back and do 12. Too many exceptions, so the odds aren't always enough on these problems. 12 is fifth root of 1728. Okay, what's harder about this problem is it's a fifth root. So we're no longer looking for doubles. We're going to look for 5 of something. Okay, so probably there's going to be 5 of the same number that go into this. What goes into 1728? Well, it's even, so 2 definitely does. I'd rather have something bigger than 2. I'm going to guess 8. It's not really a guess, but so I'm going to do 1728 divided by 8 is 216. Okay, so 8 is 4 times 2. What goes into 216? Well, it's even, so you could at least use a 2. Let's try, I don't know, will 8 work in that? Yep. 8 times 27. I'm going to circle all these bottom branches so we don't miss anything. I already got 6 2s here, so that's, we have 5 of something. Okay, 27 is 9 times 3. Okay, so we have 3 3s also. So I'm going to take the group of 5 and put it in front, because that group's going to have a fifth root. So I'm going to take 5 of these 2s and put them in front. What's 2 to the 5th? Well, 2 times 2 times. You can plug in your calculator, 2 to the 5th, you'll get 32. Okay, some of us forgot this. We just kind of normally put a square root without thinking about it. This is actually a fifth root, just like this is. Fifth root of 32 times fifth root of something else equals fifth root of 1728. So you can only multiply the same kinds of roots together. And my leftover, I see a 2, a 3, a 3, a 3. There's not 5 of anything in here, so they're going to go in the leftover pile in the back. So 3 times 3 times 3 is 27. 27 times 2 is 54. So fifth root of 54 goes in the back. That's not going to simplify. That's why it's in the leftover pile. Fifth root of 32 is, it's made of 5 2s. 2 times 2 times 2 to the 5th is 32. So when you take the fifth root of that, it's just going to be 2. You don't really have to plug it in the calculator if you kind of understand what's going on. So it's 2 fifth root of 54. And that's it. Okay, jumping to number 13. Okay, and then there will be, the last few on the quiz are like this also. So, I mean, they have letters in them, so we need to pay attention on this one. The 12 is going to work just like the last couple problems did. Fortunately, this is a square root problem, so we don't have to worry about a fifth root, finding 5 of something. We're just doing doubles. So 12, I'm just going to do this part normally. I'll come back to the letters. Is 4 times 3 and 2 times 2. So the doubles are 2. 2 times 2 is 4. Leftover is 3. Square root of 4 is 2. And, okay. I'll leave a gap there because we're going to have to put some letters in that gap, but leave the 2 and then a gap and then a square root of 3. Okay, so kind of like the numbers, the letters, to simplify, we need a double of something. Let me put it like this. If we break down a cubed, we could think of it as a squared times a. All right. A squared has a square root. What times itself equals a squared? Oh, that would just be a. And this leftover a is still under the square root, so it's going to stay inside this radical. Okay, so that's what happens to the a. So you break it up into two. There's kind of two ways to explain this, so I'm trying to figure out which way I want to go with. If you're taking a square root, really you need to have an even number up here, because it's kind of like we're dividing by 2. So only even numbers are can be divided by 2. So you just break a cubed up into a squared times a, and a squared has a square root, and this a does not have simplify, so it stays under the square root. Okay, leftovers just stay behind. Okay, that brings us to b to the fourth. Does b to the fourth have a square root? Yes, it does. What times itself equals b to the fourth? That would just be b squared. So that would go right there. That leaves nothing behind, so I don't really need this tail over here. B to the fourth actually has a square root, so it's just b squared, so that would go outside, and there would be nothing left behind. So that would be all we could do on that problem. Really, I need to do a few more examples of these with you guys, but that's all we got so far. Later on, there are a couple more problems, so hopefully that'll help. All right, jumping to number 15, we're jumping to multiply problems. It says cube root of 21 times cube root of 9. All right, if they're both cube roots, you can multiply them together, but we're going to have to simplify, so multiplying them together is not necessary because we are going to have to break it down. If I multiplied it together, it'd be like 189. But I have to simplify, so I need to do the tree thing. So I could just go back to 21 times 9. Anyways, 21 is 3 times 7. 9 is 3 times 3. So notice this is a cubed root problem, so I need a triple of something. And I have triple threes. 3 times 3 times 3 is 27. And then the leftover 7 is going to go in the back. Notice these are cubed roots over here, not square roots. What's the cubed root of 27? Normal 3. And then this doesn't simplify. So that would be it. All right. Number 17. All right, it says 20 times 63. Let's do, all right, I'm just going to put that in the calculator. 1260. This is a square root, that's good. Okay, so I went and multiplied the numbers together in the calculator. If we do the a's, I see a times a squared. What would that be? Cube, just basically adding the exponents. When we multiply the a's, we add their exponents, 1 plus 2. B times b to the third would be b to the fourth. Okay, we just saw that a couple problems ago. A to the third, b to the fourth. So I'm going to do the normal thing on 1260. Well, okay, I know it's 20 times 63. because that's how I got it in the first place. 20, 63. What goes in 63? 7 times 9. 9 is 3 times 3. So there's all my primes, all the bottom branches. Okay, we're on a square root, so we need the doubles. I see a double 2 and a double 3. So that's 4, that's 9. 4 times 9 is 36. And I see a leftover 5 and 7. 5 times 7 is 35. What's the square root of 36? Square root of 35 doesn't simplify. Okay, that's not our answer. That's the hard part, though. Okay, I'm putting the answer down here. I left some space because remember we're going to have to put some letters in. Really, this is unfortunately kind of the same as 13, I think it was. How do we simplify a cubed? Well, a cubed doesn't have a square root. Nothing times itself equals a cubed. But if I break a cubed down to a squared times a squared does have a square root. Square root of a squared is a, and the square root of this a doesn't simplify. Okay, just like a couple problems ago. And then what's the square root of b to the fourth? What times itself is b to the fourth? That would be b squared. So when you have exponents and your root, basically it's just the power divided by the roots. They're opposites, so they just divide. So 4 divided by 2 is 2. And there's no leftovers, so there's no b's left behind. Okay. 17, that's it. All right, jumping to 19. 19 looks like a distributive property. Okay, yeah, so with the parentheses, something outside the parentheses, you're supposed to multiply it into the parentheses, so that's distributive property. 35 times 7, I believe is 245. Okay, you can multiply a square root times a square root, it's just a square root. And 35 times 5. Okay, but both of these are going to need to be simplified. 245 is 35 times 7. 35 is 5 times 7. So there's our doubles. 165 is 35 times 5. So the doubles are there. All right, so on this first one, I got square root of 49 in the front, 7 times 7 in the front, doubles, and then the 5 is left over. And on the second one, I got 5 times 5 in the front, 25, and 7 is left over. Square root of 49 is 7, square root of 5, and then square root of 25 is 5, square root of 7. Okay, do these two actually add together? No, they do not. It's kind of like 7x plus 5y. It does not simplify. They both have to be the same square roots. Okay, 7 square root of 5 plus 5 square root of 7 is two different things, so it's not 12 of anything. So it doesn't simplify. So this is the final answer right there. All right, that was 19. All right, I'm going to do 21 and then stop the video and make a new one just in case I run out of space on the video. So 21 will be the last one on this video. 21 says 5 over square root of 6. Okay. Well, how do we simplify that? Well, you can't really make it any simpler looking, but you're not supposed to leave a square root in the denominator or any radical in the denominator. So how do I get rid of square root of 6? Hopefully you guys remember this from last week. If you multiply a square root times itself, what's square root of 6 times square root of 6? Square root of 36, which is normal 6. If you square root, multiply times itself, the square is going to cancel out. But whatever you multiply the bottom of the fraction, you have to multiply the top of the fraction by. That keeps the values in the same ratio, same fraction. So the bottom, square root of 36, is normal 6. The top, what's 5 times square root of 6? Does not really simplify. So that would be it. Does square root of 6 and 6 reduce? No. They have to both be the same, both normal, both square roots. These don't reduce. Do 5 and 6 reduce? Well, no. I mean, they have nothing in common. If this was like 4 and 6, yeah, that would reduce like to a 2 and a 3. But in this case, nothing reduces. So that's the end. All right, I'm going to stop this video, and then I'm going to post another video on the next day. So we're halfway through.